For now, can you just take out your notes or something to write on, so it's not in the like little prompt, but yeah, we're gonna do that in a few minutes. All right. It's like one of the like crawling. So we are going to, you guys know the quadratic formula, but I feel like sometimes like we just give you something, you're like, oh yeah, I'm like, you just trust, your math teachers. This didn't come out of nowhere. It came from taking the standard form of a quadratic and completing the square, and that's how we get the quadratic formula. So I'm going to show you that. That will be super fun. We'll talk a little bit about the quadratic formula. Once again, I know you're like semi-familiar with it because the word on the street from your teachers last year is that you did it. So we'll kind of go into it, hopefully, just reminding you of a few things and clearing up anything that you need. Some new things this year is you might have negatives under the square root, so we can take care of that with our imaginary numbers. That's like really the only thing that will be different from what you did last year. So that's kind of nice. So when I say we're going to solve this by completing the square, our first step for completing the square is we said, oh, we want this x squared to just have a coefficient of 1. We don't want a. So we're going to divide everything by a. You can even divide that by a. So we end up with x squared plus b over a x plus c over a equals 0. Whew. It feels so weird when you do it without numbers, but that's okay. Whatever we can do with numbers, we can do with variables. I want to do my setup, right? So this is the setup I do every single time. I'm going to move the constant over here, and I'm going to kind of fill in some blanks so I can actually complete the square. And we get x squared plus b over a x plus blank equals negative c over a plus blank. I'm literally doing exactly what we would normally do. We usually just do it with numbers, obviously, but whatever we can do it there, we can do here. So now we think about, well, how do I get that blank? So what I usually do is I kind of take this, right? I'm just showing you off to the side what I'm doing. I take this and I divide it by 2. So if I divide it by 2, I can just say multiply by a half. I'm just going to kind of write it like that, right? Because I'm dividing it by 2. And I square it. So that's what this is going to be. You took this and you divided it by 2. Okay, I can just put a 2 in the denominator. And you square it. Exciting stuff. I'm going to kind of simplify that out, and I'm going to write it as x squared plus b over ax plus b squared over 4a squared. Okay, so I'm just squaring everything in there. And that's going to equal negative c over a plus b squared over 4a squared. Okay. So things are maybe starting to look a little familiar. Like 4, there's a 4 in there. B squared. All right, beauteous. What are we going to do next? I'm just trying to follow my... Oh, I see what I mean. All right, I have 8,000 steps on the table here. What I'm going to do on this side is just come up with a common denominator. So if this is a, I want to make it into 4a squared. We've done that a million times. So we're going to multiply this by 4a to make that side have a common denominator. That'll make that easier for us. So we have x squared plus b over a, x plus b squared over 4a squared equals, so now I can finally get a common denominator on this side, negative 4ac over 4a squared. Ooh, that looks familiar with the quadratic formula. And then that's plus b squared over 4a squared. Okay. We're just trying to get things in kind of the same form there. Now we're going to factor the left side. and then we'll do all that other fun stuff. I'm gonna kind of come over here just so I have a little bit more room. You can still see me over here, right? Okay. So I'm gonna factor this. That's gonna factor to x. I take the square root of that, so that would be plus b over 2a squared. So remember when I factor, I'm taking the square root of x squared, which is x. I'm taking the square root of b squared over 4ac, so I just take the square root of each individual term. That gives me b over 2a squared. We still, the right side's the same. It's kind of, sorry, it's kind of annoying because you keep kind of writing the same steps because you're just doing one thing at a time. All right, so now here comes the fun part. We're going to actually start to see something happening. We're going to take the square root of each side. I get x plus b over 2a equals. I'm just going to flip these so it looks nice because, right, quadratic formula is b squared minus 4ac instead of writing like that. So I'm going to write it as plus or minus the square root. I'm going to write it as b squared over 4a squared. I'm just flipping the order just so it looks nice for our quadratic formula. Let's actually take the square root of this. Sorry, I'm losing my mind here. Oh, I just wrote it as one fraction, same difference. So if I take the square root of this, I'm going to leave it as b squared. Oh, actually, I don't want to do that. Okay, I do have to write it as one fraction or else it's just going to be ugly. I'm just going to write this as one fraction. Sorry if you just wrote it. Just make a big old one since it has a common denominator. If not, I was going to make it too messy the other way I was going to do it. Now I can take the square root because I can't really do anything to the top. But I can take the square root of the bottom. So sure, I'm just like not being organized today. My brain is not working. Sorry about my unworking brain right now, but I have b squared minus 4ac. I put it all over 4a. When we took the square root, I can't really do much to the numerator. I'm sorry, that's like awkward spacing there. I don't know. My life was in shambles. Because everything's kind of connected now and not all of those are perfect squares. But I could take the square root of the bottom. And then the last thing I have to do is just move this. And I get x equals negative b, if you want to write it over 2a, plus or minus the square root of b squared minus 4ac all over 2a. So then once again, since these have the same denominator, you can just write it as one big old fraction and then run out of room. And I'm just going to do it up here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, what a delight. That hurt my brain. Okay, that was a whole bunch of steps. Steps what we knew how to do, kind of annoying because there was variables. But the quadratic formula just doesn't come from anywhere. Someone didn't just make it up. They took the standard form of a quadratic and they completed the square. And that's where the magical thing comes from. So completing the square is great kind of if you have a nice setup. So I always like it like if the coefficient's 1, great. If the middle term's even, delightful. If there's all that messy stuff, sometimes I just don't want to deal with it. And that's why the quadratic formula is our friend, because the quadratic formula you can plug anything into and it'll kind of just do the work for you. So we'll kind of take that into account. I don't think you're going to have to derive that on anything. I'll make sure before I tell you specifically. But in general, now you just write it down and you just understand that the quadratic formula comes from completing the square. I'll leave that up for a minute. And then we just want to do one or two things with quadratic formula. But today's kind of just like a in-between day. I just wanted to check also what I actually posted on. I can't remember if I posted the answer key. I'm losing my mind here. So on Friday? Okay. Beautiful. So we were doing completing the square stuff. You were turning it in. Sorry, I just can't. I have no recollection of life. I did put the answer key up, so just make sure as you're trying things. We obviously don't have time to go over every single answer, but I can basically go over anything you want to go over. So last week on Friday, you were doing completing the square with day 2. Did anyone have any specific questions they would like to go over? I think you guys were doing, you were either doing evens or odds. I think you were doing odds. Can anyone recall, or is there anything in general that people would like to go over with completing the square before we move on to quadratic formulas? Anyone in class, anyone at home, any crowd? Okay, so I'm going off with all you guys. So today we're just gonna do kind of some quick problems. And I'm gonna explain to you the problem set and how we'll kind of break it down and what is expected of you during the week. Okay, so give me 1 second. I'm gonna erase that. Oh yeah, what's up?
So for like that one, do we have to know like exactly how it gets to that, or just that that gets to that?
Just that it gets to that.
Okay.
Yeah, you don't have to memorize those steps. Okay. Oh, I should have just looked that up because we're doing quadratic formula and let me just come up with some good numbers for us. Okay, not that. Not that. It's just not working. Okay. Now my life is just a gymnast. Okay, so we are looking at quadratic formula, so know it, love it. Just rewriting it even though you just saw it. Looks semi-familiar to you, hopefully, because I know you guys did a lot of quadratics last year. And whatever that class, Algebra 1 Geometry. Oh, let me see what I can do. 6 squared. Beautiful. Okay, finally got one that actually works. So I'm going to say solve using the quadratic formula. I'm picking this one because there's it's plugging in and that's great, but there's a lot of simplifying that goes with this one. And that's something we really do want to focus on and make sure that not only can we plug in, but we can do all the other stuff. So b squared. Oh my gosh. I'm like losing my mind today. Okay. Really gotta get back into my groove here. Okay. There we go. I was about to just give it to you plugged in. Okay. So you're looking at it, you're saying, okay, quadratic formula I like. You can always plug into it. It's always there. It's always going to work. Whereas like factoring, completing the square, sometimes it's kind of annoying. Technically, we could complete the square. But let's just do quadratic formula just to re-get used to it. So this is A, B, C. So those are just my coefficients. I'm going to start to plug in x equals, so negative B. So that's -6. We'll turn that positive, or you can just do it right off the bat. Plus or minus, underneath my square root is b squared minus 4 times a times c. And the whole thing is over 2 times a. So I'm a big pro calculator person, why not? You guys know how to do math, but you might as well not spend your year doing like silly things. So double negative, I turn positive. And I just kind of plug this into my calculator and see what it comes out to. So just be careful with squaring negatives that they do go in parentheses. So when I do b squared minus 4 times a times c, I get -12. So here's where we need all the simplifying. First thing I need to do is simplify my radical. So this needs to get simplified, so you can either do it off to the side, on a scrap sheet, I don't really care, do it somewhere. There's a negative, I need an I, so that's the big one, don't forget the I. And I can break this down. And we would write that as 2I root 3. So I'm going to rewrite this as 6 plus or minus 2I root 3 over 2. And then the last part to simplifying is you're seeing, can I reduce this fraction? So to reduce a fraction, we have kind of two terms at the top, right? We have this term and this term, and then we have the denominator in the bottom. They all need to be divisible by the same thing to reduce it. And in this case, there are, right? They're all divisible by 2. When I'm dividing, you do not touch the radical. So the radical never gets touched, it's just the numbers on the outside. But in that case, everything is divisible by 2. And that would give me my final answer of 3 plus or minus 1I root 3 over 2. And that's my, technically 2 x's, because the plus or minus represents 2 answers.
Would you get rid of the bottom?
Yep. Oh my God. Yep, just call me out today. I'm really struggling, guys. Gotta get this brain. When you don't use your brain, you really do lose it. Yeah, you would totally, because that would just be a 1. You could write over 1. You don't have to. So, quadratic formula works for all quadratics, so that's nice. So you know it's always kind of a backup. In your quadratic packet that you're going to kind of start working on today, one of the sections says solve using the quadratic formula, so that's all exciting. And one of them says solve using any method. So just make sure quadratic formula always works. It might not always be like the easiest. Like I might have even just completed the square on that one, but we were kind of just trying to go over the quadratic formula steps. But if you see another setup, go for it. And then what else is there? We'll talk about discriminant at the end of the week, so that's one of the sections in there. And then there are some nice little word problems that we'll talk about as well. So that's the main idea of this week. So as of right now, as I'm looking at my little problem set, the first section just says simplify. So we'll kind of talk about that. I might just pick one of those just to quickly go over with you. But it's kind of just like giving you this part and just saying, can you get to the end? And then there was, I'm just looking at for any tricky. Okay, there's one tricky quadratic formula one that I'll go over with you because I think when I saw it, I was like, but then it actually wasn't that bad. But sometimes we see something different and we freak out a little bit. Are there any general questions about quadratic formula? I feel like you guys knew how to do that like before you even came here. But if you don't, or if you don't know what's going on, please ask a question. Sorry, I'm trying to see my chat. So I'm going to pick 2 problems. I'm doing them right out of this problem set. So if you're in front of me, you have it in front of you. If you're at home, you can either do it separately or kind of print it out and have it there. I just wanted to kind of go through each section and do one of each section. So you kind of get the deal. So section 1, simplify each expression. Once again, it's just kind of the going through and doing the breakdown and the reducing and all that fun stuff. So I'm just going to pick a random one. I'm going to pick number, I don't really care, number 2, I guess. So from the problem set, number 2. So just a lot of simplifying in this section. So all you would say to yourself, because you get to this part during the quadratic formula problem, is what else can I do? Always check your radical. That's usually the main thing that you can simplify. If I break that down, that would be we're at 2 root 5. Bless you. And then once you have that done, can I reduce anything? And in this case, I see that all of the terms are divisible by 2. And that would give me my final answer of 3, plus or minus 1 root 5, or you don't even need to write the 1, you can just root 5 over 2. And that's really all you have to do for the first section. So any of the other ones, same idea. Can you break down a radical? Can you reduce a fraction? And then you're kind of done for 1 through 8. So I feel like sometimes when they're too easy, people get confused as well. So that's that. Sorry, I'm just trying to find ones that might be a little different. You guys should be able to do that. I should ball still up. Okay, I'm gonna skip to the one that when I saw it, I was like, eh. So I feel like you would maybe say eh too when they get confused. So I'm gonna skip to 19. We'll just do the hardest one on there first. Get it over with. Then all the other ones will seem easy. Number 19. Okay. So the reason we'll want it's a proportion, so we're gonna have to cross multiply it. So that's kind of just annoying just to get the setup. But there's eyes. So I feel like if people saw eyes, they'd be like, what the heck do I do? So let's just go through the steps and see what happens. I'm gonna cross multiply this. Okay, I'm gonna just take the 2 binomials and distribute them. So when I do that, I'll get 2x squared. And then I would get what, plus 6. Did I write xi or ix? Ix. Wait. Oh yeah, sorry. Combining. And then plus 1 ix, right? Just I times x. Plus 3i squared. Okay, so just doing that, like it takes a second. You just want to make sure you're good. I'll combine stuff in a second. Let me just cross the other way just to kind of get all the proportion stuff done with. So I'm going to cross this way. And I'm going to get 3x squared. What will that give me? Minus 3ix plus 4ix minus 4i squared.
Ooh.
Okay. So I'm going to stop here because that one takes a second just to kind of process that. Once again, we're going to do the hardest one, and then all the other ones won't seem that bad. But remember, as you're getting to problems, you might have to do a little bit with the setup. We want things in standard form. So we want them to be ax plus bx plus c equals 0. This is our major form. We do always want to equal to 0. So just as a heads up. So as I'm simplifying, I have 2x squared. I can combine these to get 7ix. And then remember, I squared is -1, so that's actually just -3. And then over here we have 3x squared. If I can combine those two, I'll get 1ix. And then that's really -1, so that would be plus 4. I'm just pausing just so people have a minute to get caught up. So now let's put it in standard form equal to 0. I'm just going to move everything to the right so then I always like to make my quadratic term positive. So I'll move the quadratic over here. That just gives me 1x squared. I'll move this linear term. It does have that I, so that's a little funky. That gives me -6ix. And then I'll move my constant. Okay, so this is our standard form of the equation where we're going to get A, B, and C from. From here, it's really not that bad. So I feel like the I is going to throw us off. It's not. So we're just going to go through the steps and kind of just see what happens. When I'm thinking of this, though, A is 1. B is -6i. So that I, remember the x is the variable. The -6 goes to the constant. And then C is 7. So I'm going to plug in. Let's see what we got. X equals -b, so I'm just going to make it positive, right? 2 negatives make a positive. Plus or minus the square root of b squared minus 4 times A times C all over 2 times A. So we're just getting used to plugging back into that formula. We haven't really used it a ton this year, maybe once or twice. But just going from there. So I'm going to simplify under here. And what I notice, I know that negative 6 squared is 36, and then I have I squared. So that would give me 36I squared. I know that I squared is negative 1. So this is really just negative 36 minus 4 times 1 times 7. So it kind of took care of itself when I squared it, that we don't really even have that I anymore, which is kind of nice. So I have negative 36 minus 4 times 1 times 7. And that's going to give me, underneath my square root, negative 64. Ooh, that's actually not bad. I say to myself, hey, what can I do from here? Well, I can simplify the radical. So I get 6I plus or minus. If there's a negative, there's an I, and we know the square root of 64 is 8. So that's looking way better. And then at this point, if you can combine things, please do so. With a plus or minus, I can, since these are both imaginary, I can combine them. So I'm going to do 6I plus 8I over 2. And I'll do 6I minus 8I over 2. That would give me what, 14 over 2, which is 7I. That's my first answer. And then 6I minus 8I is negative 2I divided by 2 is negative 2I. Oh, what a beauty. Nope, that's not negative 2I. That's negative 1I. What is wrong with me today? Gosh, sorry guys, negative 1. So, the reason I did that is because I wanted to, let's just get the hardest problem over with. If you had probably seen that and you've gotten it to yourself and I never mentioned it, you'd be like, what the heck is going on? But we literally did everything the same exact way we would do another problem. Were there some I's there? Sure. Did it really make the problem that much harder? Not really. It just meant that we had some I's in our answer, so not a big deal. So we'll see more of those as we go. But the moral of the story today is, if you're not in standard form, rearrange and get in standard form. So ax squared plus bx plus c equals 0. Make sure you are equal to 0 before you start. And then that gives you your a, b, and c, which you're plugging in. And then from there, it's just a whole bunch of simplifying. So use that calculator. If you need help, just ask for it. Little things like negatives under radicals or breaking down radicals are going to be important. But basically, we started with the hardest, and all of the other ones should seem pretty easy compared to that one. So I am not checking these day by day. So I know I've done that in the past, but it just makes like 8,000 more things for me to check. So here is what I will tell you. This is going to be due, this entire packet. Sorry, I'm just thinking of one thing, like when we got each individual section done. I'll be done by Friday. It's due on Monday, the 1st, so you have a week, at class time. So at, whenever the heck we start this class, 12:36. So if you're at home, if you're here, you'll obviously have it. If you're at home, you'll be submitting it right when class starts. Now, with that being said, the reason I did that is I know like one day you're busy, the next day you're not, you're rushing one day, you have time the next day. If you have a study, maybe you have some extra time, things like that. I don't want to just be like, do 20 problems tonight. And you're like, I don't have time. So this at least lets you spread it out. You have a whole week. At the current moment, you should be able to do numbers 1. Well, you could do the first section, 1 through 8. The second section is just quadratic formula. That's 9 to 19. We already did 19. And then the other section after that is solve using any method. So you can solve by factoring, completing the square, quadratic formula, or square root. So technically you know how to do those. I'll kind of go over tomorrow, like, hey, maybe this one, like, what setup does this lend itself to? I'll help you with that. But right now, you can pretty much do up to number 46. It's like a 20-minute lesson. Because a lot of it's review, and some of it, this new quadratic formula stuff you've seen, but hopefully the stuff we did today kind of refresh your memory. Refresh. So just as a reminder, things like numbers 14 and 15, you don't want to plug fractions into the quadratic formula, that's disgusting. So just clear the fractions by multiplying by the common denominator. Numbers 16 to 18, just, do a little bit of simplifying, but get it in standard form. And then for a lot of the other ones, it's just like, just do your thing. Like if you think square roots is easiest, do square roots on the any method thing. Some of them are a little, really, none of them are too bad, I'm going to be honest with you. And we'll go from there. So what I'm going to do is, for people here, we have to take a mask break in a few minutes, so we'll just do that like the last few minutes of class, because I feel like I'm going to keep talking and then never get back in. For the people at home, I'm just going to take this down.